Students, so today we will learn about uh, degree of accuracy. Okay, so in the previous video we have already learned about the estimation by the orders of magnitude, large as well as small. Okay, so today we will learn about the degree of accuracy. So what is actually the degree of accuracy is, so from degree of accuracy we means how far we can measure a quantity without any error or estimation. So it is degree of accuracy means how far we can measure a quantity without any error of estimation. Okay, without any error of estimation. So in any experiment all observations should be taken with the same degree of accuracy. So if we take different degree of accuracy, then obviously our observation will be different. Okay, so in a given experiment it is no use taking one observation of very high degree of accuracy than the rest of the observation. It is because it will not make final result more accurate. Okay, now it is observed that the accuracy of a result of an experiment is same as that of the least accurate observation. So you need to remember this paragraph, that is the accuracy of a result of an experiment is same as that of the least accurate observation. Okay, so suppose we take one example. Suppose it said that in the determination of diameter of wire. Okay, so suppose wire is there, obviously the wire will be very thin. Okay, so to find the diameter of a wire we find experimentally, that is its length with meter scale and its volume by measuring cylinder. Okay, now it is useless to find length correct to 0.1 millimeter as we cannot measure the volume correct to 0.1 millimeter cube. Okay, fine. That's why the degree of accuracy will be determined by the accuracy to which the volume can be measured. So if we can measure the volume accurately 0.1 centimeter cube, okay, then we can measure the length to 0.1 millimeter also. Okay, so you need to just remember the definition of the degree of accuracy. Okay, so you write this definition in your copy. So the degree of accuracy. Okay, so next we will move to the percentage error. So here we will get 4-5 formulas, so you have to remember that. So before we find how to calculate the percentage error in a result in a given experiment, let us see and give an idea of the absolute error. Okay, so before going to the percentage error we need to first understand what is absolute error. Suppose we take one example. So in the determination of density of a solid, okay, so our experiment is to determine the density of a solid and the experimental value is, suppose after experimenting our value is 2.50 gram per centimeter cube. However, the actual density, this is the experimental value. So after doing experiment we have got 2.50 gram per centimeter cube, but actual value is our 2.35 gram per centimeter cube. Okay, so what will be the absolute error? Absolute error will be the difference of the actual measurement minus experimental measurement. Okay, so if we subtract that we will get the absolute value, or sorry, absolute error. So absolute error will be the difference of the experimental value minus the actual value. So this will be the our absolute error. So after calculating the absolute error, then only we can calculate the percentage error. So the percentage error can be calculated by the following formula. So this will be the formula which you have to write it in your copy. Okay, so percentage error, that is absolute error divided by actual value into 100. Absolute error was 0.15, whereas the actual value was 2.35 into 100. So you will get the required percentage. Okay, so to first calculate the percentage error, first what we need the actual value, absolute error. So first you need to write the absolute error formula. So what is absolute error? It is experimental value minus actual value. So if you first write this definition number 1, then after that you just write the definition number 2. Okay. So you can see the another example also. So experimental value is 985 and your actual value is 981. So then first we need to calculate the absolute error, that is 985 minus 981, it is 4 centimeter per second. So therefore percentage error equal to absolute error by actual value into 100. So after solving this we will get 0.40 percentage. So two questions are there, practice problem. So question is that a student calculate experimentally the value of density of an iron as 7.6 gram per centimeter cube, and if the actual density is 7.6 gram per centimeter cube, calculate the percentage error. So to find the calculation, to find the percentage error, so first you have to write actual not actual, absolute error. What is absolute error? Our experimental value minus absolute value. So experimental value is 7.4 minus actual value was 7.6. So how to do this? Okay, so as the difference, as the experimental value is less than your actual value, so what we will do, we will write the bigger value first. Okay, then only we will write the smaller value. So 7.6 minus 7.4, this will be 0.2 gram per centimeter cube. So we have got the absolute value error. Now we can put in the percentage error. So percentage error will be equals to absolute error. You can use this formula. Absolute error is 0.2 divided by actual value. Actual value was our 7.6 into 100. So if we solve this, we will get 2 by 76 into 100. So after solving this, obviously we will get 2.63 percentage. So first one is done. So you can similarly solve 2 and 3. So you can treat all this as homework. So if you find it difficult, then you can directly contact me, then I can give you the solution. Okay, fine. Next we have the effects of combining error. Effects of combining error, that means all observed value are subjected to mathematical treatment in order to find the result of an experiment. So it is not possible to produce great accuracy by mathematical manipulation like addition, subtraction, multiplication or division. So suppose we give some examples, and with this example we can understand the effect of combining error. Okay, so question number 1, addition and subtraction. So when a number of values are added or subtracted, the result cannot be more accurate than the least accurate value. That means suppose we are adding 5.283 with 72.5. okay, so answer is we are adding 3 numbers, that is 2.000014. So if we add this all the 3 numbers, so we have got 79.78314. So in the above addition, the value 72.5 has least accuracy. It has only accuracy up to 1 decimal place, only 1 decimal place, whereas this number have accuracy up to 3 decimal place, and this number has accuracy up to 345 for 5 decimal place. That means 72.5 has the least accuracy. So when we say 72.5, it implies that the value lies between 72.45 and 72.55. okay, and 72.5 is the most probable value. Thus error in 72.5 is plus minus 0.5. How? Because 72.5, 5 means 50. So this can be written as, either it may be your 72.45 or it can be written as 72.55. That means because 72.55 is equal to 72.50 and 72.45 is also equal to 72.50. If it is 5, if the first number is even, then we increase it. But if the last number is 5 and if the digit previous to it is odd, then we write the number as it is. Okay, so that means we can say that 40 is equivalent to 40 if we round off it. So 41 is equivalent to 40, 42 is equivalent to 40, 43 is equivalent to 40, 44 will be also equivalent to 40, round off. Okay, now 45, if it is 5, then first you have to look the number before 5. It is, if the number before 5 is odd, then you have to write as it is same, but if it is even, then you have to increase it by plus 1, so that it is before 5 the number is 4 and this 4 is even number, so this will be equivalent to 50, round off. 46, obviously it is number is greater than 6, greater than 5, obviously it will be 50, and 47 will be also 50, 48 also 50, and 49 is also 50. But sometimes if you see 35, okay, so number before 5 is odd, so it will be written as it is, that means it will be treated as 30 only. Okay, but if it is 45, then it is treated as 50. Okay, so that means, so if we say that 72.5, we are in 72.50, okay, so 72.50 either can be written as your 72.45 or 72.55, both are same. So that means what is the error? We have to subtract these two, then only we will get the error. So if we subtract it, it will be obviously 0.05 and plus minus. Okay, so thus the error is 0.05. So as the final result can be more accurate than the least accurate observation, therefore it is absurd to put the answer 79.78314. We cannot write this 79.78314. So therefore the correct and the most reliable answer is 79.1. Why? Because the least degree of accuracy is 72.5. That is, number after decimal is only 1. So after adding, we have to write the number only up to 1 decimal place. Okay, so answer will be 79.7 only. Fine. Suppose we take another example, multiplication and division. So when a number of values are multiplied or divided, the error in the result is the sum of the percentage error of separate values used. That means, suppose we take one example. If the length of a side of a square is measured such that the value is 10 centimeter, then the error in measurement could be 10 plus minus 0.5. That means the error in the result is the sum of the percentage error of separate values used. So suppose the measurement could be your either it may be greater than 0.05 or it may be less than 2, or either the result may be increased by 0.05 or it may be decreased by 0.05 only. So how to calculate the percentage error? That is the absolute error. So absolute error will be your this part 0.05 divided by actual value. Actual value was 10 into 100, that is plus minus 0.5%. So this will be our percentage error. Okay, so as the area is the square of the side, therefore percentage error in measuring the area will be your this percentage error plus 0.5. That means this is the portion. The error in the result is the sum of percentage error of separate value used. Sum of percentage error of your separate value used. That means percentage error in measuring area will be your plus minus 0.5 plus 0.5. That is, if we add it, we will get plus minus 1 percentage. Fine. So we have the last topic 1.11, significant figures. This is very important topic. Okay, so the number of the significant figures to which the final result of an experiment should be stated depends upon the following factors. The first factor is that the nature of experiment and the accuracy with which the various measurements are made. So first we need to know the nature of the experiment, and second we need to know the accuracy at which the various experiments has been measured. So if we see the example, so in example number 1, So in the determination of value of g, that is the acceleration due to gravity, at a place with simple pendulum, the length can be measured correct to 0.1 centimeter. Similarly, the time period of a pendulum can be measured correct to 0.5 seconds. That is, it is not desirable to state the value of g as 980.432 centimeter per second square. So the correct value will be 9.8 into 10 to the power 2. That means we have already stated. So how we write the number? Order and magnitude. So a number between 1 and 10 into powers of 10. So this is the format to write. So 980.432. So how we will write? So we have to put this decimal here. Then only it will become a number in between 1 and 10. Okay, and we can write the other numbers also, but as the accuracy is up to decimal to correct to decimal to 1 decimal place, so 9.0432 correct to 1 decimal place can be written as 9.8 into how many digits we have moved? 1 2 digits, that is 10 to the power 2. So this is the correct way of writing it. Okay, okay. So yes, fine. If the accuracy is between 1 and 100, then the correct value of g will be 9.80. So which gives the your significant figure? Just 10 power this will give the number of significance. This 2 is the significant figure, that is 9 and 8. And similarly in this example, so 9.80, if we write 9.80 into 10 to the power 2, so then the correct value of g will be, however, if the accuracy is between 1 and 100, so if we write the accuracy between 1 and 100, then we have to add just 1 0. So again, if we write the accuracy in between 1 and 1000, then we have to just add one more 0, 9.800 into 10 to the power 2. Okay, so it is upon our correct to which decimal place we are using it, either 1 to 100 or 1 to 1000 or 1 to 10, like this. Okay, so you can understand it with this example, that is 1.0. So 1.0, so this is the number between 1 and 10. Similarly 1.05, it is the accuracy between 1 and 100. Similarly, if 1.053 after decimal, if it is three numbers, then it will be number between 1 and 1000. You can see if the number of digits between the decimal is 2, that is 0 and 5, there are 2 digits after the decimal, so the accuracy will be between 1 and 100. So from the above example, it is clear that the number of significant figure automatically gives the accuracy of the result in the experiment. Okay. So in the exercise 2, so you can write this. We have already discussed this one, first one. What do you understand by the term of order of magnitude? So treat this as homework. Why are the physical quantities expressed in order of magnitude? Support your answer. So okay, so one is homework. B, I will solve the B, I will give the solution of B. So you solve equation number, this one, express the order of magnitude of the following quantities. Suppose if I do the first one, so it is number is 1 2 5 7 8 9 3 5. So we have to write, how we have to write? A number between 1 and 10 into powers of 10. Okay, so there is no point here, so how we will treat? So point will be in the extreme right, so we have to bring that decimal where? In between 1 and 2, 1 2 3 4 5 6 7, here, then only it will become 1.2578893 this is the number between 1 and 10. But if you put the decimal in between after 2, it will become 12 and it is greater than 10. So into how many digits we have placed? 1 2 3 4 5 6 7, so 10 to the power 7, like this. Okay, so you solve. What do you understand by the term degree of accuracy? We have discussed among the various physical measurement recorded in experiment, which physical measurement determines the degree of accuracy. So you can do this and state the formula for calculating percentage error. So what is the percentage error? It is your absolute error divided by actual value into 100. This was the formula. You can write it Is it possible to increase the degree of accuracy by mathematical manipulation? Support your answer. So I am giving this as homework, so you try it. If not, I will give the solution. State the factors which determine the number of significant figures for the calculation of, so I will give this solution. So the final result of calculation in an experiment express the number in terms of degree of accuracy between 1 and 10. So the number is 1, 2, 5, 3, 4, 7, 200. So we have to write the accuracy between 1 and 10. 1 and 10. So 10. 10 means after decimal one number should be there. One digit should be there. So how we will put 1.2 into 10 to the power, where the decimal was in the extreme right. So 1, 2, 3, 4, 5, 6, 7 and 8. So 1.2 into 10 to the power 8. Similarly, if you write between 1 and 100, so 100 means after decimal we have to put two numbers. So it will be 1.25 into 10 to the power 7. Okay, so like this. So you do it, and if you find any difficulty, then we will discuss it on the next class or next video. Okay, thank you.